Okay, so for the first do know in week 6, it's a fighting scientist passage. So that means that you'll be doing a lot more reading than in the data analysis. The first question says, the discovery that many tektites contain unmelted crystalline material would. And you need to decide if it's going to weaken one of the scientist's argument or be incompatible. So it says contain unmelted crystalline material. So scientist 1 says tektites are most certainly extraterrestrial, probably lunar in origin. That just means that he thinks they come from the moon. Scientist 2 says non-local origin is extremely unlikely. So he thinks that these are Earth organic tektites. And then we need to know what unmelted crystalline material. So he thinks extraterrestrial, he thinks Earth. And then you just go and you need to find the key terms in each of these passages. So scientist 1 says that they never contain unmelted crystalline material. So the answer here is A. It's going to weaken scientist 1 argument, and then you just literally find that sentence in the middle of the passage where it says that they do not contain crystalline material. Which of the following is a reason given by scientist 2 for believing that tektites originate on Earth? The density of the Earth's atmosphere would prevent any similar lunar. Tektites have a composition totally unlike that of any material. An extraterrestrial material could not have been as widely dispersed. Or material ejected from the moon or beyond would eventually have been much more widely. So we need to go back into the passage, read scientist 2, and say why he thinks that these are from the Earth instead of from the moon. So if you go back and you read through, the next time it's orbit, there are striking similarities not between the composition of the Earth crust and most tektites, so he says they're very similar. They were probably formed by meteorite impacts. The shock wave produced by a major collision could displace the atmosphere above, and then the material might splatter into suborbital heights and undergo air friction melting upon re-entry. So if we look at the answers for here, material ejected from the moon or beyond would eventually have been much more widely distributed on Earth. The answer here is J. Because he says they do resemble Earth materials, but he doesn't say that they don't resemble lunar materials, so that we know they can be ejected from the moon. H actually is the second best answer. This would be your distractor, but it has it backwards. It says that it would not be widely distributed, but we know that from reading the passage that it would be widely distributed. Question 3. Scientist 1 could best answer the point that some tektites have vesicles filled with gases in the same proportion as the Earth's by. So how would scientist 1 explain that we see similarities to Earth composition in tektites? Because he says that they are from the moon. So countering that not all tektites have such gas-filled vesicles, that's a terrible argument. Whenever you're having an argument, you should just not say, well, not all of them apply. That's life, too. Demonstrating that molten material would likely be likely to trap some gases while falling through the terrestrial atmosphere. That's a better option. Suggesting that those gases might occur in the same proportions in the moon's atmosphere. That's also okay. And showing that similar vesicles filled with these gases in the same proportions are also found in some terrestrial volcanic gas. So it's not going to be D, because that says that it's still terrestrial, so we want to avoid that answer. So right now we're in between B and C. And the answer here is going to be B, demonstrating that molten material would be likely to trap some gases, because then as it flows from the moon and goes into our atmosphere, if we can say that other materials on our Earth will trap these gases, then that would explain why these would be in the same proportion. How did scientist 2 answer the argument that tektite-like material ejected from the Earth could not reach a high enough velocity relative to the atmosphere to undergo air friction melting? So that's, again, going to be going back to the passage for scientist 2, and we need to talk about air friction melting. So, terrestrial material might then splatter to suborbital heights and undergo air friction melting upon re-entry. Tektite fields in the Ivory Coast and Ghana can be correlated with known impact craters. So he's saying that, again, these are from meteorite craters. Even if a tightly focused jet of lunar matter were to strike, whatever was deflected would remain in a solar orbit. The next time its orbit coincided with that of the Earth, some of the matter would be captured by Earth's gravity and fall over a wide area. So, the answer to number 4 here, he said that they did not reach a high enough velocity relative to the atmosphere to undergo air friction melting. And he says that they do melt. Let's look at the answer choices. So, by asserting that a shock wave might cause a momentary change in atmospheric density, permitting subsequent aerodynamic heating, that's reasonable. By pointing out that periodic meteorite impacts have caused gradual changes in atmospheric density over the eons, that doesn't give you what would happen at that moment, so we're going to cross off G. By attacking the validity of the aerodynamic studies cited by Scientist 1, this doesn't actually give you a claim that he would use, so that's never going to be the answer. If they just say that they're going to disagree, then that won't be the answer on the ACT test. And then by referring to the correlation between tektite fields and known impact craters in the Ivory Coast and Ghana. All this answer choice J says is that there's evidence that there was tektites and a meteor at the same time. So the answer here is F, because this is the only one that addresses the fact that it gives you an example of what could cause heating and then how it would happen. So the answer choice for number 4 is F. And then number 5. The point of subjecting lenses of tektite glass to a heated airstream was to determine their water content, see if gases became trapped in their vesicles, reproduce the effects of atmospheric entry, or simulate the mechanism of meteorite formation. So the answer to number 5 is C, because we want to see what happens when it enters the atmosphere and whether we could see if it would trap gas, we could see if it would go through air friction melting, and then we could see which scientist was right. This is the only one that actually talks about a scientific procedure and why it was used, so this is an SIN standard question. The passages don't mention water content, and it doesn't, we don't want to know how meteors are formed, we want to know where the tektites come from. So the only 2 answer options here are B and C. Gases trapped in the vesicles would help if you go back to the theories in question 3, but then reproducing the effects of atmospheric entry, this is the argument point for both scientists. They want to figure out if it's terrestrial or if it's lunar based on how it behaves when it enters the atmosphere, and so C is the only answer that discusses that.